Hi everybody, I'm Disha Jindal and I'm going to present this paper called Is Guilt More Significant Than Fled? A Contextual Model for Salient Event Detection. This is joint work done with Dan Deutsch and Dan Roth at the University of Pennsylvania. Given a very long piece of document like this or a bunch of multiple documents, it is often required to understand the entire text and then extract the key information from it. This problem of extracting the key information from text has been studied at multiple granularities. In this particular work, we have focused on events. Events because they make the core part of the most sentences and at the same time represent a very compact semantic unit. As we can see in this example, the event fled with its arguments 2,100 Colombians and the fighting across the border carries its meaning very effectively. Additionally, a salient event detection task has been shown to be central to many downstream tasks such as summarization, storyline creation, and question answering. Next, we'll formally define the problem of salient event detection and briefly talk about the dataset. Then we'll discuss in detail our proposed model and share the insights on the evaluation metric and the key results. And finally, we'll discuss how the salient event detection task can be helpful for the downstream task of extractive summarization. Salient event detection is the task of finding the most salient events from a given piece of text. Most prior work on this task is based on heuristics, except there has been some recent work which defines a salient event as the most co-referenced event and focuses on identifying those. Most closely related work on salient event detection is based on kernel centrality estimation, and it focuses on capturing the interactions between different discourse units. But we believe that events are highly contextual and none of the prior work is expressive enough to capture that. So in this work, we focus on capturing the context by using a rich event representation, incorporating inter-event interactions, and the global document level context by designing a number of global features. For the dataset, we use the event salience dataset by Liu et al., which is based on the New York Times annotated corpus, which is a large corpus of articles that were published between 1996 and 2007, along with their corresponding summaries. The salient event annotations for this dataset are based on the hypothesis that salient events are the ones which appear in the summary. Here is some of the statistics of the dataset. We had around 600 million document summary pairs for training, 64K for validation, and around 64K for testing. But there are a bunch of issues with this dataset. First, the lemma matching between the abstract and the body is not perfect. Second, given the lexical matching procedure used for salient events, some documents do not have any salient events, so we filter such documents. And finally, we filter the instances with some other missing details and work with the cleaner 80% of the original dataset. Here is the high-level architecture of our proposed solution. The three main components of our solution are richer event representation, global document level features, and inter-event interactions. Next, we'll elaborate these components one by one. Starting with the first one, let's look at these two documents. Both of these documents have a killed event and a fled event. As we can see from the annotation of the salient event in red, a fled event is salient in the document on the left, whereas the killed event is salient in the document on the right. This demonstrates what might be very intuitive to us, that just looking at the trigger word of the event is not sufficient to decide its salience. The subject 2,100 Colombians of the event fled increases its significance, and similarly the subject Palestinian radicals along with the object the Israeli Minister of Tourism increase the significance of the killed event on the right. Inspired by these observations, we augment the representation of the event mentioned with its subject, object, time, and location information. And here is how we incorporate this into our model. Given a document, we identify the event mentioned and then find the subject, object, time, and location by running the SRL. We then embed these attributes by passing the token level BERT embeddings through different BILSTM modules. Uh, Although BERT embeddings have proven to be highly beneficial for a large number of tasks, they may not encode all of the information that is useful for this task. This is especially true for the high-level document features along with long-range dependencies. Therefore, we augment the event representation from the previous slide with the features that leverage the event structure, document-level statistics, event-event relations, and event abstractions. Starting with parent score, this feature leverages the hierarchical relations between events in a document with an intuition that the higher level and more abstract events are relatively more salient. We use the model from Wang et al. To identify the parent child relationship between every event pair, such as the killed is the child of the storm event in this example. And then the parent score of each event is defined as the number of child events it has. Next is frame name. This provides a more abstract understanding of the event compared to the event trigger. Here we have all the event triggers under the frame killing, and we can see that the frequency of all the events within a frame is very different. Since their salience in the text is usually the same, this feature enables the events with low frequency to leverage the understanding from the more frequent events under the same frame. Next, we have two of the most commonly used features, which is the location of the sentence in which the event appears and the frequency of the trigger in the document. We then leverage the event structure to design the next two features. Argument frequency of an event is the maximum number of times any of its arguments appear in the document, and the named entity argument feature signifies whether any of its arguments is a named entity. And here is how we incorporate these 6 features into our model by simply appending them to the embedding from the previous stage. Now let's look at this excerpt from a document. The first 4 events here are fled, shooting, killed, and wounded. If we look at the first event, a young Kuwaiti man fled to Saudi Arabia alone, versus event 2, which is a terrorist shooting in Kuwait, followed by the same young Kuwaiti man fled to Saudi Arabia. We can see that event 2 has increased the significance of event 1. Similarly, event 3 and event 4 mention the killing and the wounding caused by the shooting event, and thus increasing the severity and the salience of the shooting event. Uh, this gives us an intuition on how the interaction between events influence their salience. And so we model these interactions by adding an inter-event attention layer at the top, thereby allowing one event to increase or decrease the salience of the another event. Before moving on to the results, let's take a look at the evaluation metric used by the previous work, some of its drawbacks, and our proposal to rectify those. Precision at K and recall at K, where K is 1, 5, and 10, are the metrics previously used for this task. However, there are a bunch of issues with these. For example, let's say there are 2 documents, the first one having 8 salient events and the second one with 20 salient events. The maximum value of recall with this definition is variable across documents. For example, the maximum recall at 5 for document 1 is 0.625 and for document 2 is 0.25. And even if the model identifies the salient events perfectly in both documents, document 2 contributes zero point 0.5 and document 1 contributes 1 to the overall average recall at 10, which makes it difficult to comprehend the model's performance fairly. So we propose a normalized recall at K instead, which has a maximum value of 1 for all documents, and different documents contribute fairly to the average recall. Additionally, as shown in the global features, the trigger frequency of salient events is more than non-salient events, on an average 6.76 versus 2.18. So if a model has very good co-reference ability, more frequent events will influence the results more. So to get rid of this frequency bias, we propose modifying the evaluation methodology to only look at the unique salient events instead. Now let's take a look at how our model performs compared to the 3 baselines. First two, the location and frequency are the simple heuristic-based methods, and KC is the model by Liu et al., which we briefly mentioned in the beginning is based on the kernel centrality estimation and focuses on identifying the interactions between different discourse units in the document. It adds a 10-point improvement in precision at 1 and the recall matrix on the simple baselines of location and frequency. Now, if we look at our model, it performs better than KCE on all metrics. It adds a 4% improvement on the model's ability to detect the most salient event. The improvement is consistent even with the higher values of K, with 2.9% and a 1.9% gain in precision at 5 and 10, and a 4.1% and 2.4% gain in the recall at 5 and 10. The global document level features played a very significant role, as we can see in red here, in our model's overall performance that we saw in the previous slide. Here are the numbers from the ablation study on the features to understand what contributes most to the gains. Starting with frame name, which adds the model's ability to understand the events, specifically the infrequent ones, contributes almost uniformly to all metrics. As the value of K increases, the benefit of the sentence location and the trigger frequency features increase, signaling that they provide a crude but rather significant signal for salience. Parent score feature captures the event sub-event relations, and it has shown to be very helpful for this task, especially in recognizing the most salient event among these. Finally, argument frequency and named entity features contribute marginally more to the recall than precision. Now let's take a look at the potential benefits of modeling the event salience for the downstream task of extractive summarization. Extractive summarization systems are trained on binary labels assigned to each sentence to indicate whether or not that sentence should be selected to the summary. And the most common procedure for obtaining these labels is to greedily select sentences to optimize the Rouge score. Uh, we proposed an alternate event-based signal where we select the sentences containing the salient events. To compare, we quantify the two labeling procedures. Here is the set of all the sentences selected by the Rouge-based oracle, and these are the sentences selected by the alternate proposal. Now, if we look at the mutual coverage, the event-based signal covers 80% of the sentences selected by the Rouge-based summary, whereas the Rouge-based summary only covers around 50% of the sentences, leaving a lot of the salience events behind. Additionally, the Rouge-based method is not as fine-grained. And if we look at the proportion of salient events in the sentences selected by Rouge, 27% of those are non-salient. This suggests that modeling the ground truth at the event level, which is a more compact semantic unit, might be helpful. One more advantage of event salience is that the output from an event-based system is much more informative. This is one salient sentence as per Rouge, which contains 10 events. So rather than assigning one score to the sentence, an event-based system can provide a much more informative signal onto why this particular sentence might be salient by assigning a salience score to each of the constituent events. So these are some of the ways in which the extractive summarization task could benefit from event salience. All right, to conclude, I presented a new model for event salience detection, which incorporates a richer event representation and allows interactions between events and provides the new state-of-the-art results for the task. Ablation study showed that explicitly incorporating abstract event understanding through frame embedding and hierarchical event relations provide very good complementary signals for salience, along with the traditional signals of sentence location and trigger frequency. We propose a more comprehensible and intuitive evaluation method for the task. And finally, we discussed how event salience can be helpful for the downstream task of extractive summarization. For the code and the data, please use this link or scan this QR code. Thank you so much for listening to this talk.